Welcome to the Explainer. Today, we're completely bypassing the fluff to demystify JavaScript. Seriously, if you've ever felt totally overwhelmed by how this language behaves, you are in the exact right place. We're going to look right under the hood of its core mechanics together. So forget everything you thought you knew, because we're taking this down to its absolute fundamentals, so you literally never have to search for another explanation again. All right, let's dive right in.
Here's our roadmap for today. First, the interesting story of JavaScript. 2, variables, specifically var, let, and const. 3, what is scope? 4, hoisting and the TDZ. And finally, number 5, primitives versus references.
So, Section 1, the interesting story of JavaScript.
To really get why JavaScript has some of these, well, let's call them quirks, we actually have to understand its incredibly rushed origin story. It explains so much about why the language works the way it does today. So back in the day at a company called Netscape, a guy named Brendan Eich created a language to add logic to web pages. And get this, he built it in just 15 days. Originally, it was called Mocha, but nobody was really paying attention to Mocha. At the time, Java was the absolute hottest thing around. So over a few drinks, an idea was born: let's rename Mocha to JavaScript so people think it's an advanced version of Java. It was a brilliant marketing trick for sure, but it left a legacy of bizarre behaviors because, again, the language was literally built in 2 weeks. Eventually, a standards body called ECMAScript had to step in. Huge updates like ES5 and especially ES6 were introduced to finally fix those early loopholes and standardize the whole thing.
Moving on to Section 2, variables, var, let, and const. That brings us perfectly to how we actually store data in this rapidly built language. We do this using some very specific keywords. At their core, variables are just data containers. Think about an ATM. When you pop your card in, the machine has to remember exactly who you are throughout the entire transaction. If it somehow forgets whose account it's accessing before it spits out the cash, well, that's a massive problem. Or imagine a video game. The program needs to constantly hold on to your character's score as you play. Our code uses variables to remember this vital piece of data across its entire lifecycle.
So, the real crux of the matter is how we declare these variables. We have the old way, using the var keyword from ES5, and the new way, using let and const from ES6. Now, the source material makes a really strong case for completely, utterly abandoning the old var. Why? Because it quietly ignores extremely dangerous actions. For example, it silently allows you to declare the exact same variable twice. It's kind of like eating junk food all day and having parents who never ever correct you. You just keep going down a bad path without even realizing it until it's way too late. On the flip side, let and const actually protect you. If you make a mistake, they throw helpful errors right away, basically forcing you to write secure, clean code. Generally, you use let when a value is going to change, like that game score, and const when a value should never change, like the value of pi, or the name of a groom at a wedding.
Which leads us to Section 3, what is scope? This builds directly into that core concept of scope. Scope is all about the boundaries in your code, where these variables are actually allowed to exist and be accessed. But before we back those boundaries down, I want you to really think about this question. Exactly why are we so harsh on the var keyword? I mean, I mentioned it was buggy, but its biggest architectural flaw has everything to do with how it handles its scope.
When we map out these boundaries, we see 3 main types. Global scope means the variable is available anywhere in your entire code. Function scope means the variable is confined inside a specific function. Both var and let respect those two just fine, but here is the kicker: block scope. A block is anything confined inside curly braces, like an if statement. Let and const securely stay within those curly braces, but var, it just completely ignores block scopes. It breaks right out of those curly braces and dangerously leaks out into the rest of your code. This right here is exactly why modern developers stick to let and const. They actually respect the boundaries you set.
All right, Section 4, hoisting and the TDZ.
Now, what's really wild is that JavaScript does something super weird behind the scenes before it even runs a single line of your code. Let's start with hoisting. When you write a variable, the engine secretly splits that line into 2 parts. It takes the declaration, the part where it acknowledges the variable even exists, and it hoists it to the absolute top of your code. But it leaves the initialization, the actual value you assign to it, behind on the original line. Because of this, if you use var, you can actually access a variable before you've officially written it in the code, but it frustratingly just hands you a placeholder value called undefined. No error, just empty, useless data, which can cause massive, massive headaches.
To fix this massive headache, ES6 introduced the temporal dead zone, or TDZ, specifically for let and const. Now, do let and const hoist? Yeah, they do actually move to the top, but instead of giving you that buggy undefined value, JavaScript traps them in the temporal dead zone. This is an area in the code from the very top all the way down to where you actually assign the value. If you try to access the variable while it's inside this zone, JavaScript will rightfully throw a secure error saying, hey, this cannot be accessed before initialization.
To make this concept really stick, I love this perfect analogy from our source material. Imagine asking for the keys to a Mercedes-Benz at age 15. The JavaScript engine is basically a parent who knows that the variable, the Mercedes, is definitely coming in the future, maybe when you turn 22. But because you're currently 15 and stuck in the temporal dead zone, it rightfully refuses to give you access to it right now. It acknowledges the car exists in your timeline, but it strictly blocks you until the proper time. And finally, Section 5, Primitives versus References. Let's dive into how JavaScript fundamentally categorizes all its data. It basically lumps everything into two very distinct buckets. First up, we have primitives. You can think of these as your straightforward, built-in values. The easiest way to spot them? They do not contain any visual brackets in their syntax whatsoever. So whether it's a string like a name in quotes, a number like 12, a boolean like true or false, or even null, undefined, symbol, and big int. Basically, if it doesn't have brackets, it belongs to the primitive family.
Now let's contrast those primitives with references. In the source material, this is wonderfully described as the game of brackets. Any value containing square brackets for arrays, curly brackets for objects, or round brackets for functions automatically falls into this much more complex reference category.
So the crucial point here is how these two types behave when you try to copy them. When you copy a primitive variable into a new variable, JavaScript gives you a brand new, independent clone. It is a real copy. If you change the new one, the original stays exactly the same. But references? They are completely different. When you copy an array or an object, you are not making a clone. You're making a shared copy. JavaScript just gives the new variable another key to the exact same original piece of data.
We can visualize this crazy behavior with a shared car analogy. If you and your friend both have your own independent cars, like primitives, and you crash yours, your friend's car is perfectly fine. But with reference types, it's like saying, my car is now your car too. You share the exact same vehicle. So if two variables share a reference data type and one variable modifies or crashes it, the other variable is automatically affected because they are literally looking at the exact same data. You have to be incredibly careful when copying reference types.
Which brings us to the end of our journey under the hood of JavaScript today. We've looked at the rushed 15-day history, the boundaries of scope, the safety net of the temporal dead zone, and the mechanics of data types. But I want to leave you with one final actionable question to reflect on. Are you still using var in your code? Or are you leaving your data vulnerable to the quirks of a language built in just 2 weeks? It really might be time to fully embrace let and const. Thanks for exploring this with me today, and keep questioning your code.